All right, so this is lesson 4.4, and I'm going to go ahead and let you do the warm-up on your own, and then you can always check with me if you wanted to see if those answers were correct. So in 4.4, we're going to be looking at some reasons for proving triangles congruent, and those two reasons we're going to look at are SSS, which stands for side, 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 and SAS, which stands for side, angle, side, to construct triangles, and also looking at using those to prove triangles are congruent. So let's talk first about triangle rigidity and what that is defined as. That is, triangles are the strongest figure. Okay, so if we look here, we have this as a representation of this side corresponding to this side corresponding to this side, and they're congruent, and then AB congruent here to ED. So if we have all three sides, then we know that triangle ABC is congruent to DEF because they have all three sides, and that is a reason that we can prove triangles congruent. So let's take a look at this proof here. Go ahead and fill in what you already know, which we know the given, so you can go ahead and put both of those on the given line, what we're trying to prove, which goes down here, and then we'll take a look at what goes in the middle. All right, so this is what you should have so far. So now, if we have these two and these two, we need the third side in order to prove side, side, side. So how can we mark this third side congruent to itself? Well, DU is congruent to DU, because when something is congruent to itself, that's called the reflexive property. And then lastly, we can prove those triangles are congruent because we have all three sides. So side, side, side is our reasoning. The next one we're going to talk about is side, angle, side. So as long as we have a side, then we have its included angle between the two sides. So it has to go in order: side, then the angle, then the side, then the angle, then the side. Then we can use side, angle, side to prove triangles congruent. So be careful because it has to be the included angle. And what that means is the angle at the intersection of two sides, at or formed by the intersection of those two sides. So let's take a look at this next example here. So go ahead and fill in what you already know. It tells you what you're trying to prove, and then it gives you what you know so far, that G is the midpoint. And then you also know this. So start with midpoint, and then you can put this kind of as step 2. All right, so I can't really fit it all in there, so I'm going to go ahead and put the other given as step 2, and then just add an extra line there down at the bottom, kind of an extra step there so that I can separate my givens to have room for them both. So let's go ahead and take a look at what's next. Well, if they give us the word midpoint, we're probably going to define it. So if we define midpoint, EG is congruent to GI, and FG is congruent to GH by definition of midpoint. So we have this is congruent to this, and this is congruent to this. All right, so now we need either another side or another angle, but it says use side, angle, side, so that means we need to use an angle. So this is the included angle. Well, how would I prove this angle is congruent to this angle? What kind of angles are those? Those are vertical, and we know vertical angles are congruent, and that's the reason, vertical angles theorem. So that would be angle FGE congruent to angle IGH. And then lastly, what is the reason the triangles are congruent? Well, it kind of gave us the reason up there. Use side, angle, side. So side, angle, side is our reason. Our next examples looks like we wants us to show the triangles are congruent with x being 5. So this would make this 5, this would make this 7, and this would make 3 times 5 minus 9 is 15 minus 9, which would make that 6. So we can show that MN is equal to PQ. Check. We can show that NO is equal to QR. And then lastly, we can show that MO is equal to PR, because they're both 6. So it worked out. All sides are congruent to the other triangle sides. So we're going to do that same thing for this one. If you want to try it and pause, and then you can push play and check when you're ready. We want to show ST is equal to VW. We want to show that the measure of angle T is equal to the measure of angle W. And then we want to show that TU is equal to WX. So go ahead and show those things, and you can push play and check when you're ready. All right, and so here's the proof kind of working backwards to show that y is equal to 4 on each of those 3, which shows that it does work, that ST would be equal to that, and so on and so forth. On these next examples, we're going to determine if we're going to use side, 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 or side, angle, side, or neither, if we can't prove they're congruent, and we're going to mark our diagram. So it looks like we already have a side. Let's see, what else can we mark? We could mark this one congruent to itself, reflexive. So it looks like we only have 2 sides. So side and side, that's neither. We can't do anything else or mark anything else, so we can't use either of those. On this one, we can mark this, and it says A is the midpoint of JN. So if A is the midpoint, then we know this is congruent to this, and then I'm going to go ahead and mark that with a 3rd. There we go. So we have all 3 sides. So that means we can use side, side, side. All right, on this next one, we could go ahead and mark this side congruent to itself, and then KA bisects JKN, JKN. So that would mean that this is congruent to this. So it looks like we have a side, we have an included angle, and then we have another side. So side, angle, side could be used on that 3rd one. So go ahead and fill in what you can on this next proof, and then we'll continue together after you've got the givens filled in and then what we're trying to prove. All right, so here's what we have so far. Filled in the givens, filled in what we're trying to prove. So now let's go ahead, and it's already marked in our picture, the givens. What can we do next? Well, we can mark this side because of the reflexive property, right? So BD is going to be congruent to itself, BD, by reflexive. Then let's think about, what about parallel lines and cut by a transversal? We can mark the alternate interior because we have parallel lines. We can have angles CBD and ADB by alternate interior angles theorem. So now it looks like we have a side, we have an angle, and we have a side. So side, angle, side to prove those triangles are congruent. So try that last one. Fill in what you can here of proofs, and then let's see if we can go from there. So all the givens here on just line 1, and then what we're trying to prove, that these angles, not triangles, triangles up here, triangle congruence here, so it's going to be either side, 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 or side angle, side, but then the corresponding parts of congruent triangles are congruent. We can prove parts of the triangle after we already know the triangle is congruent. So let's go ahead and fill these in. So what's going to come next to prove the triangles are congruent? If we know that these two sides, which are already marked in the picture, what else is missing? Either angles or this third side, right? We don't have any way to get the angles because we don't have any other information. So it has to be this third side. And so the way that we can mark that is it's congruent to itself. So LN is congruent to LN by the reflexive. Property. And then that used side, 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 all three sides. All right, and then our last problem here is going to be talking about what this length would be. So if this is 15 and this is 15 and this is 10 and this is 10 and this side's 18, then what would this side have to be? Well, if we're looking at corresponding kind of parts, we know that it's congruent to that, that's congruent to that, that's congruent to that, and we know that these triangles are congruent to each other, then AB would have to equal 18 miles by CPCTC because the triangles are congruent and the triangles are congruent by side angle side because we have these angles in here. So we already know the triangles are congruent side angle side, so we know that if that's 18, then that has to be 18 by the corresponding parts.